It's been a while since I last really posted anything. Any sort of project, any game, live stream, anything. The only thing I really posted was just a couple short little animations every now and then, but I haven't really done anything since then, because I've been busy with 2 jobs, and YouTube really doesn't make that much money for me, and ever since I turned 18, it's been more about getting myself started and getting my own place to live and buying food. So YouTube wasn't really my priority, but everything has been pretty good so far. Finally had time to do something. So yeah, I'm still alive. And I did so much research for this run project. I feel like you guys might like this one. So I was watching YouTube and I just see this random video pop up. What if warrior cats had realistic cat genetics? I was like, you know what? I am having a stressful day at work at Popeyes. Not the best job ever, but I decided to watch it, and it was pretty interesting to think about. I had no idea some of these genetics. I had no idea that there was like only 2 real cat colors in the wild, and I was like, you know what? I want to do this with my series. So thank you to KiwiQueen13 for inspiring me to do this, but that's my inspiration. What I had to do next was terrible. For about a whole month, I was researching cat genetics, and I found a whole playlist with 8 whole videos by Blue Collar Den explaining cat genetics. I watched every single video. Each of them were about 10 minutes long. The longest was 14 minutes. I skipped the Warrior Cat special because it wasn't necessary, I didn't think. But I decided, now that I know all these genetic things, I wanted to do this for myself, for my series. And so I did. I only picked out a few cats, like the most known families, like Silverstones family. I like Cream Frost's family since it's so big. She had 5 kits in total. I also picked the families of the main characters, like Tansy Pool and Firewing. I did Honeywing's family. So this is the family tree I have so far. This is what I'm going to be basing this is what I'm going to be applying the genetics to. Now, I did this whole family tree after I went over my notes, and I realized that some of my drawings were inaccurate, so I'll be pointing those out when I get to them. Firstly, though, I learned genetics in 7th grade, and to my knowledge, not all of you are older than middle school, and you might not be familiar with genetics. So I'm just going to have a little simple explanation here. So each cat has 2 pairs of what we call an allele. That is what decides what color your cat is, or what eye color your cat has, or if it has long or short fur. So these are always represented by capital and lowercase letters. Capital letters are called dominant, and lowercase letters are called recessive. Now this square I have here is called a Punnett square. This is how we figure out what the possibilities are for the kits. I started with the example a little bit complicated, but I'm trying to simplify it as much as possible. So we have a completely black male cat. His genes are capital B, capital B. If he has kits with the female cat that's completely orange with 2 dominant O's, we could create the Punnett square like this. Black and orange are the 2 wild cat colors that you could have. You've seen other cats. There are brown cats, there are like light brown cats, gray cats, but I'll get into that because the base colors are black and orange, and all those other colors come from that. What we have here are B-O kit, and since both the B and the O are capital, they're both dominant. And this black and orange come together and make a tortoiseshell cat. So there's a 100% chance that this black cat and this orange cat will have a tortoiseshell baby. But that isn't actually the case because male cats can only carry one color gene, and tortoiseshell cats need to have two color genes, the black and the orange. So male cats can never have a tortoiseshell color unless they have a mutation, which is pretty rare. But for my series, I'm going to say there are no mutations for the X chromosomes. So if we have a black cat and an orange cat, and they have a male kitten, instead, the male kitten's going to have a 100% chance to have the female's color, which is orange. Now here's where the grays and the creams and the light browns and all that come in. There's a separate gene called a dilution gene. It's a recessive gene, so both have to be lowercase d's to be in the kitten. Now I have a diluted black male cat with an orange cat that isn't diluted but carries the dilution gene. Since dilution is recessive, a cat could carry the gene but not express it. Now first on this Punnett square, we need to figure out what the colors are actually going to be. And like the previous example, all of the kittens are going to be tortoiseshell, unless they're male, in which case they're going to be orange. Now we create a separate Punnett square for the dilution gene. When we combine both the genes from the parents, we find that half of the kittens will be diluted and the other half won't be. Now this is only a chance. It doesn't mean that if you have 4 kittens, 2 of them will be diluted and 2 of them won't. There's just a 50% chance for each of these cats to be diluted. So there might actually be a chance that all 4 of them might be diluted and all 4 of them might not be diluted. When I did the redesign of all the cats, I tried to make it pretty even with the chances. So combining the colors and the dilution genes, we get 4 possibilities for both genders. It's really only 2 because each of them have a duplicate in the Punnett square. But if you're looking at all of them, it's 4 different colors, depending on the genders. For the females, we have a regular tortoiseshell and we have a diluted tortoiseshell. For the male, we have a regular orange and a diluted orange. Now I need to explain the colors. So orange and black are the only colors you could find in the wild. The chocolate and cinnamon you see here are actually mutations from the black color. So when we're doing the Punnett square, how do we figure out what the kitten's colors are going to be if we have all 4 of these colors on our chart? Well, orange will always be dominant to black. Black will always be dominant to chocolate, and chocolate will always be dominant to cinnamon. Now, there are also the diluted versions of these colors, which are cream, blue, lilac, and fawn, which also follow the same dominance order. And again, being dilute or not depends on a completely separate gene, the dilution gene. It has nothing to do with color. So you don't have a cream gene, you don't have a blue gene, you just have the orange and black, and if you have a mutation, you have the chocolate and cinnamon colors. Now, the white gene is a little confusing. The white gene is completely dominant over every single color. But if you have a white cat, it doesn't mean that it has the white gene. It might also be the white spotting gene, which is more common. Now, I only include this complicated gene because I chose to put Nightwhisper on the family tree, and her father is a white cat. So I decided he's going to have the white gene, and I'll explain it when we get to their family tree. But basically, the white gene is pretty rare, and it dominates over every single color. Another thing with the white gene is that the cat who has that white gene can only have blue eyes, orange eyes, or odd color eyes. Now, the white spotting gene is a semi-dominant gene, so there's no capital S, capital S. There's only capital S, lowercase, and lowercase s. The spotting gene is dominant, and there are 10 different levels of spotting. I'm not actually sure what determines what level they are, but for the sake of my video, I decided that if one of the parents has a spotting gene and the child has a spotting gene, I'll just have the same level. But for some reason, science says that level 5 must have a parent that's level 5. But again, I'm just going to ignore that. And for my video, if a parent has a certain level, I'm going to make the child have that level. The tabby gene is actually a gene by itself. It's a dominant gene to the solid color cat. Now, orange cats are a little different. All orange cats have tabby stripes, but it doesn't mean they carry the tabby gene. So if you breed two orange cats together, they might not even have a tabby gene and all of their kittens might be solid color. That's just science. I don't even understand it, but just know that all orange cats have tabby stripes, even if they don't have the tabby gene. Brown and black tabbies look similar. They're both brown, but the brown tabby has brown stripes while the black tabby has black stripes. There are two different type of tabby patterns. I'm not going to include the spotted one because that is more of the domesticated cat. It's not found in wild cats. And also the genetics are a little bit confusing with the spotted stripes. So the macro pattern is the most common since it's dominant. It's the stripes you usually see. But the classic tabby stripes are those little marbly patterns, the little swirl patterns you see on cats. That's more rare since it needs two recessive genes to be present. The silver and the gold gene are also very complicated, but basically it's possible to have a silver wildcat, it's possible to have a golden wildcat, but they're both recessive, and for the silver cat, the cats always have pink noses. There are 4 different types of cat eyes. There's amber, blue, green, and hazel. Now, blue is recessive, while amber and green are dominant. Now, when amber and blue are together, since blue is recessive, amber will show up. When green and blue are together, since blue is recessive, green will show up. But when amber and green are together, since they're both dominant, they actually make a hazel color. Alright, now I could finally get into the new redesigns of these cat characters. So starting off, we have Bramblestar and his mate Squirrelstar. When first looking at them, if you had no idea about cat genetics, they look like they would be a family. They look like the kids would be plausible to be their kids, you know, the same colors. But here's the family after genetics are applied. Now, like I said, I super overviewed the notes after I created all these drawings, and this is the first example which is a little incorrect. So since brown is a mutation of black, black is actually recessive to orange. So amber kit, moss kit, and dust kit should actually be orange like their mother instead of chocolate like their father. Squirrelstar no longer has the white paw, but she does have a mild white spotting, which is passed on to amber kit. Bramblestar has yellow eyes, while Squirrelstar has green eyes, which combined make hazel eyes for all 3 of the kits. If you haven't watched Season 1 of the Westwood series, you're probably a little confused about who these cats are, but this is Lucy's family. Lucy is the little kit over on the right. Her parents are Blackbird and Serval, and her little sister is Luna. As you can see, Lucy inherited everything from her mother, and Luna inherited everything from her father. So, you know, that makes sense, right? But here's what they actually look like with genetics. The first thing you might notice is that Lucy is completely black now, because black is dominant to what Serval is, which is the diluted cinnamon. And even though cinnamon is a mutation of black, black is still dominant to its mutations. So both the Blackbird's kits have his black color. Luna also lost her fluffiness, because fluffiness is actually recessive, and since Serval doesn't have fluffy fur, both of the kits don't have fluffy fur, but they do carry the fluffy genes. So if Lucy or Luna has kits with a fluffy cat, they could have a fluffy baby. Luna also gets green eyes from her mother since blue is recessive and green dominates over the recessive blue. Speaking of Lucy's children, here's Liontail and his first litter of kits. Obviously, Liontail is a golden tom with very fluffy fur. Since you saw that Lucy's genetics changed to be a completely black cat, Fire, Oak, and Fox are going to be very different once you see the real genetics. So here are the real genetics, and you could see that all 3 toms inherited their color from their mother. Not because Liontail's color is recessive, but because all toms will receive their color from their mom. If they were on the right, you could see that Fire is still fluffy. Why is that? Even though Lucy is not fluffy, because of her father, Blackbird, she carries the fluffy gene. And when she had kids with Lion, Fire actually inherited both recessive fluffy genes, which is why he's fluffy and his brothers are not. For our first game protagonist, we have Honeywing and her family. Liontail also had kids with Jade, which is a silver cat, which again is recessive and pretty complicated to explain, but I'll try my best. But from her original picture, you could already tell she's going to be a silver cat with some sort of white spotting. Now here are Jade and her kits with genetics applied. Now as you can notice, all of them are tabbies. Why is that? It's because every silver cat also carries the tabby gene. And why are they all silver instead of golden? It's because golden can only be created with two very specific kinds of silver cats. It's a very rare occurrence in the wild, but I just made Liontail golden just because that was his original design, and obviously it didn't get passed down the family tree. Jade has her green eyes, and you can see Sunkit and Honeykit both have hazel eyes, because Liontail, as you remember, has amber eyes. So amber and green, they're both dominant, they create hazel. Now for the most iconic cats family, Silverstones, parents, Lilac Path and Rhyhart, and her two sisters, Crystal Kit and Heather Kit. Now already you could probably tell that there are no such thing as completely red cats, so it's going to be a little weird seeing this family once the genetics are applied. Now before I show you their new designs, I need to tell you that calicos are pretty much just tortoiseshells with the spotted gene. So calicos and tortoiseshells are the same thing, except calicos are more patchy and tortoiseshells are more grainy. Now here's this iconic family after we applied genetics to it. Rhyhart had to be turned into the closest thing to red, which happens to be orange, and Lilac Path had to turn into a tabby because she was a silver cat. Red eyes also don't exist in wild cats unless they're albino, but none of my characters are albino, so I just left that gene out completely. So I had to change Rhyhart's red eyes to an amber color. And his amber and Lilac Path's green made hazel eyes in all three of their kits. Now on to Rhyhart's brother, Redclaw. He is also a red cat, which you know is going to change into an orange cat. Now if you remember what I said about orange cats having kits with a black cat, you could probably guess what the kits are going to look like now. So here I have applied the genetics, and first thing you notice, Redclaw is an orange cat, and Sparrowtail is actually a tortoiseshell. Since in her original design she had both black and brown, I decided why not have a tortoiseshell mom for one of these families. Here is also one of the examples I did previously when I was talking about the Punnett squares. Sparrowtail carries the black and orange gene, while Redclaw only carries the orange gene. This will result in tortoiseshell cats. But like I said, male cats can't be tortoiseshell, so what's going to happen? They're going to inherit a color from the mom. Since the mom here has both black and orange, I decided Stormclaw should have an orange color. He could also be black, but I decided orange was closer to his original design, so I decided orange. Everyone here also has amber eyes, because again, red eyes don't exist. Webfoot is the only cat on here which I gave a white gene. Now white dominates over every single color, so if you take Webfoot and mate him with any other cat, you can imagine what Nightwhisper is going to look like. With real genetics applied, here are the two. You have Webfoot not looking any different, except he doesn't have the black spot on the end of its tail. But Nightwhisper is completely different. She is completely white because her father carries the dominant white gene, which was passed on to her. Now she is completely white with her mother's dominant eye color, amber. Cream Frost and Gemstone had 3 different litters and 5 different kits all in total. 2 of which were male and 3 of which were female. Now I decided to put them all in one picture, even though Bree's kit wasn't born by the time Foxpaw died and whatever. It's just easier to show them all in one picture. Now Gemstone has a pretty unrealistic pattern. You already know that's going to change, but Cream Frost is pretty much going to have the same color. Now here are the new designs. Now both Cream Frost and Gemstone look a little different than the other examples. They're actually both diluted. Gemstone is a black cat, but since he has the dilution gene, he is actually a bluish gray. And Cream Frost is an orange cat, but since she has the dilution gene, she is a cream. Now because both the parents have dilution genes, all of their kids are going to be diluted. If we ignore the dilution gene for a bit, you can see that there's a black cat and an orange cat. And of course, all the females are going to be tortoiseshells, while the male cats inherit the color from their mother. Now reapplied dilution gene, and now all of the orange cats are a cream color, and all the tortoiseshell cats are, instead of a black and orange mix, it's a blue and cream mix. Crystal Blaze's kits are very confusing on their designs. They are extremely different from each other and pretty different from their parents. Now obviously it's going to be a very surprising change when you actually see their new genetically accurate versions. Like I said before, golden is very difficult to get, and neither of the parents are silver, so that's pretty much impossible to have. Now here are the updated versions of our 4 kits. As you can see, silver was still a possibility, since Crystal Blaze carried her mother's silver gene with her, and breeding with another cat that carried a silver gene, they were able to create Wisteria Kit. Now how did Sunfall get the silver color? Well, if you remember, Jade was a silver cat, and she passed it on to both of her kits. So in this universe, Sunfall is actually a silver cat. The 3 other kits got their orange color from their mother. Onto a completely separate part of the woods, we have Nightmare and Crash Lily. Now Nightmare is all over the place with his design. I actually have no idea if it was an OC that was given to me or if I created it myself. But if I created it myself, I am very disappointed in what I did, because he is just all over the place with his colors. And that's obviously going to have to change when we apply the real genetics to it. Now here we are, Nightmare is now a completely black cat, and Crash Lily is a diluted orange cat. Now, as you can probably remember, a black and orange cat create tortoiseshell female kittens. Now you could probably be asking yourself, hey, how come Tansy Kit and Briar Kit aren't diluted like their mom? If you remember, the dilution gene is actually recessive, so both the parents have to be carrying the recessive dilution gene, which Nightmare is not, so these kits will not be diluted. Going back to Honeywing's family, we have Ivy Heart and her 3 kits, Bee Stripe, Sea Flower, and Sear Stripe. I'm actually not sure if I got those right. As you remember, Honeywing's design was changed previously, so Bee Stripe is going to change dramatically. But her 2 other daughters, CE and Sear, they come after their father, but if you use your common sense, there are no cats with that blue of a pigment, so obviously all 3 of them are going to change. So here are their new versions of themselves with genetics applied. Ivy Heart was changed to a black cat with a dilution gene, so he's more of a gray-blue to keep up with his original design. Since new Honeywing Silver is recessive, all 3 of her kits got the black gene from their father. Honeywing wasn't carrying a dilution gene, so all 3 of her kits weren't a diluted black, so all of them were completely black. They didn't resemble their father whatsoever. Now hold on a second, you may be asking, how come there are 3 different eye colors on this page? One of them isn't even hazel. Now if you remember, Honeywing had hazel eyes, which means there's a yellow and a green gene. These genes could be separated to have one kit having green eyes and one kit having yellow eyes. And since Ivy Heart has blue eyes, there's no way that any of the kits could have hazel eyes like their mother. Now, I completely forgot to create Flame Pelt, but you know what she looks like. She's a completely orange cat with brown freckles on her face. Now, if you could just imagine for a second, if we applied real genetics to her, she would just be an orange cat with the tabby stripes and green eyes, which is possible in wild cats. Now, you remember that Firewing ended up being a completely black cat when Lion was bred with Lucy, who was also a black cat, which came from the father. Now, for a dramatic change in the character designs, here are genetics included. Now, Lightning Tail is the generic orange cat with the tabby stripes. Nothing else on him. He has green eyes, like his original design, but he doesn't have those white spots because neither of his parents had the white spotting gene. You might be a little confused on Gorsefur because, yeah, she's a tortoiseshell because her parents were black and orange, but how come she's diluted? Remember that Firewing's mother was Lucy, and Lucy's mother was Serval, who had a dilution gene. Now, it is possible for someone super high up in the generations to pass the recessive gene all the way down many generations and end up in Gorsefur. Now I decided just because Gorsifer's original design was diluted, I was going to make Flame Pelt carry the dilution gene but not express it. So it would be a capital D and a lowercase d. So this is why Lightning Tail isn't diluted while Gorsifer is. Now for our last example, we have Little Bird and her 3 kits. Because of my design, Robin Fur is actually a male, but my design, I said that he was going to have just really big eyelashes, so he would look more feminine, but he was still, a nude cat. But that isn't really important, because once you see the genetics, everyone's chocolate. Now, I did make a mistake on this one, because I forgot that orange is dominant to black, which is dominant to chocolate, which is dominant to, But if I did have to fix this, all 3 of Little Bird's kits were actually going to be orange, because Lightning Tail's orange color is actually dominant to the chocolate mutation. I decided Little Bird should have hazel eyes, since brown isn't a possible color and hazel was pretty much the closest thing to it. So combined with Lightning Tail's green eyes, we have 2 kits with green eyes and 1 kit with hazel eyes. And there we have it, our updated family tree. I personally don't really like any of them, except for maybe Cream Frost and Gemstone's family. They were actually pretty cute kits. But when making story and making games, you can define the characters more if you step out of the genetics and create your own design. Silverstone has her very iconic calico design. But if we went on to make her a generic orange tabby, she wouldn't be as memorable. So if I wanted to be scientific and make all my games genetically accurate, I just feel like each character wouldn't be as memorable. Because honestly, if Firewing didn't inherit the fluffiness from his father and his mother, I don't think anyone would remember him. Because in the original games, he was always that character with the super emo bangs, and eventually he became our main antagonist, and that may not have happened if I followed cat genetics. So in conclusion, forget science, do what you want. If you're an artist, if you don't want to follow genetics, you don't have to. Just have fun and do what you want to do. I'm working on a secret project. I'm not going to tell anybody, but I did post about it, and I said I was probably going to publish this project first, but I'm going to be working on this project, and I can't wait to show you all. I'm pretty sure you guys have been waiting for this. I'm pretty sure you might have forgotten it, because it's been a whole year since it was even mentioned. But, that's going to be your only hint. It's been a year, okay? So, stay tuned, I guess. I'm so cringy, I want to go bury myself in a hole. Okay, bye!